Right, so we've got another one of Alan's sets here, and this is a Harvard 402 MPA. Now, there's something not right about this. Is something not the right colour? I don't know. I'd have to look at photos of others. I don't think it's all supposed to be black like this. Is it the right knobs, the wrong knobs? Have they been painted? Is that what's wrong? I don't know. But what it has come with, it's actually come with the right kind of power lead. Wow. So we'll get that connected up to our test gear. And switch on. So this is one of my favourite sets. Okay, well it doesn't do anything. So let's have a look. There's a connector in the lead, which is because this has been made up somehow. It's me who can't plug it into the power supply. It's not the radio at all. There we go. That's better. I got it plugged into the negative, into earth instead of negative. Right, it's come with an intercall mic, so standard replacement mic, branded Intercall, who were business to a radio company, or probably still are. So that's fine, that's just like our standard replacement mic, but we'll come to that later on, and we will use our standard Cybernet wired mic. This is Cybernet 002F radio, just like the real Amstrad is and the Mustang is. But this has the advantage that it doesn't have the Roger bleep. So I've got no, I don't think there's any notes with it. So we'll get it through service procedure. So it'll, just like with the Mustang and anything else using this chassis, if we get less than 3.5 watts out of it, we'll change the transmitter ballast resistor, and if we get 3.5 watts or more, we won't. There's no fake ones, no cheap ones. So far so good. That looks absolutely factory. Okay, so we've got a pin come out of this connector. I'm just going to plump up the little catches on this. That one is a bit pushed in. That's definitely clicked into position. Right, we'll get it connected up to the test gear. I've done Mrs. Thingy's shopping this morning. She's 90 odd. So I've been into Grantham, 7.5 miles away, and done that. Still going on and off. Oh well. So I can't see anything problematic there. I'll look at the VCO. Just to make sure it's somewhere near. Go to channel 40. Or is it done on channel 1? It really doesn't matter as long as I get what I'm looking for. want our negative to probe to an earth point, so we'll use one of the coil cans. Far side of that capacitor, the green one. Wouldn't it be nice if it was just a retune and test with no repairs needed? He's also sent in one of those CTE preamplifiers. Do you remember the on-the-air preamplifier? He sent one of those in. She's no doubt bought off eBay and has no doubt been blown up by a burner brigade person. That's fine. It's kind of 3 volts both ways. Check it on channel 1. Two volts. 1.6. Yeah, it's sensible both ends, so that's fine. You can end up with a minus voltage on these. So that's the receive VCO, that's the transmit VCO, and the test point is the far side of this green resistor. I've shown these in great detail in other videos that use this chassis. So, trouble with these ballast resistors is a lot of these are only 3 watt capability, so you can't really be expecting the set motor to do more than 3 watts. And we swapped these for 6 watt ones, so don't need to change the value, it's just they're not going to get as hot and drop. Right, let's go for transmit, picture in picture on, and we'll fill in see what it's doing. So we'll go to channel 20. Key up. Is picture in picture on? No, it's not. And we are getting what? 3.4 watts. Channel 1. 3 watts. Not normally that way around. 3.1 watt. Back to channel 20. This thing keeps going on and off. I want it on low power. Not adjustable, it's 240 milliwatts. And our transmit current in full power is 1.249. I think that's a bit high for that power output. Right, we'll go through it. So it's a matter of centralising the peak on channel 20. So that's slightly different. Same power output, but the peak's in a different place. Again, the peak's in a different place. No change with that one. Needs more heat. Especially as it's freezing point outside. Now that's absolute peaks, it's 3.4 watts. So just need to look at these coil positions because Mr. Coil Stretcher can play with these. No, we're not going to get more than the 3.4 watts out of that, and I want it to be 3.5, so we'll change the ballast resistor. Right, so that's changed for a much higher quality one, and I've put 3 ohms. It's supposed to be 3.3, but it's got a bit of a fighting chance with a 6 watt resistor in and a very, very slightly lower resistance. If you ever see these linked out, make sure you put the resistor back because it will kill the PA if it hasn't already. Those transistors are about £16. We've all seen these ridiculous YouTube videos get 8 watts out of an Amstrad and all that, and it isn't going to happen. And you're not going to get much better range anyway. It's not going to. We've been through this a million times. 8 watts isn't twice the range of 4 watts. It's about 5% more. Right, put the power back on. So we're now at 4.1. We're going to need to reset this one and that one. It's now capable of 4.2, so we'll just drop it to 4. See if that's now something like within 0.1 throughout the 40 channels. So on channel 40, spot on 4 watts. On channel 1, it's 4.05, so that's alright. Current consumption is now 1.27. It's gone from effectively 1.25. So for 20 milliamps, we've gone up half a watt. Now it will have affected low power, it may have made it worse. So of course it's supposed to be 400 milliwatts, but there's no now legal requirement. It's now 300 milliwatts, that's better. Just landed the lid on the microphones. I may have edited out that racket, I may not, we'll see. Right, the meter is probably banging. Oh, the meter doesn't light. Haha. It's going to be fun, isn't it? Do you know what? The meter's still not. It still needs to come up a bit. It's supposed to be in the centre of the red zone. It now is. Deviation. Let's see where that is. Probably somewhere silly. Wow, it says 1.5, but we'll verify that with my other test set. However, we're going to plug in the instrument speakers and see where we are with receive. I keep saying I'll take that attenuation off this. While I'm at it, I'll plug the PA speaker into the PA socket. We'll kill several birds with one stone. PA. Testing 1 2, testing 1 2, testing 1 2, 121. That is absolutely as distorted as anything. So we've either got a Duff audio IC or we've got Duff capacitors. It's dreadful. That's going to be fun to fault find. Let's go back to CB. Dirty controls as well. Let's put the signal generator on. 2779125. Oh, we don't know whether this thing's on frequency yet, do we? So we'll just put that in. Channel, that's right at the top of its travel, so chances are it's got a worn out crystal. So we've got it up to 79,100. That'll do. Really needs to be better than 79075, something like that, which it is. So 2779096, 2779100. So reference crystal could do with changing probably in the next 5 years. So we'll now put that in on the signal generator 79100 so that we tune it up exactly as to the frequency it's on. Alright, so we'll go to the SINAD meter. My goodness, this is sensitive, but then they usually are. So it's for 12 dB, it's 0.23. For 10 dB, it's 0.2. For 20. 0.85. Right. So I'm going to swap the PA speaker for that speaker. That doesn't sound distorted on there. How weird is that? Let's go back to PA.
Testing 1 2, testing 1 2, testing 1 2.
Absolutely fine. You know what? I bet the PA switch was dirty, and flicking it backwards and forwards a few times has fixed it. I've got a bit of dirt on the volume control. So I wanted to see where we got to with squelch. So go back to the speaker. I'll put the attenuator on the inset picture and see what we can put on full squelch. I like it to be 100 microvolts. It is 100 microvolts exactly. So these aren't tiled with the same brush as the fake Amstrads where you struggle with the squelch, and we've put a different preset in. All the coils are different on those. 100 microvolts. Something we're not going to have to fiddle with today. And the threshold .7. So I'll go through the receiving and I'll take a break. So signal generator to 100 microvolts, oscilloscope on the inset picture, and we'll plug into the instrument speaker. And make sure we've got a peak on the detector coil. That looks right. Right, we'll go over to the SINAD meter. Do the front end. Bring up the signal a little bit, do the IFs. You can also look at the meter on the radio for these. There we go. Look at our new SINAD reading. So go back to, oh, I'll leave it there. .2 for the 10. Difficult because we go on to another range. 0.65. Yeah, it's still 0.2. We have difficulty reading accurately under there. Right, squelch. It may have affected the squelch, so I'll just put the other speaker back in so you can hear it too. .100 microvolts. I'm sorry, 30 microvolts. See if we can squelch that out. We can. 100 microvolts on the signal generator, and in it comes. While we've got 100 microvolts on the signal generator, we'll do the meter, which is reading plus 30. should be 9. So that's that done. Right, other end, set squelch, signal drains are on. Not 0.75. So we've got deviation to do, and we've got the mic. So we'll do the deviation right now. Just check it with the quartz lock 282 test set behind me. Wow, it's quiet. It is quiet, just like my Marconi test set said. Let's put it to there. Put the other glasses on. Wallow. Wallow. That's it. So Marconi wasn't lying today. So basically we've just got the meter lamp to do now on this. Somebody's asked if I'd show how they're done on a Cybernet 134 set. So I'll try and do that. I'll look for a Cybernet 134 with a Duff meter, and we'll do that. But not today. Right, we're going to change this meter lamp. And I've run out of meter lamps. So I'm going to do something which is ridiculously expensive to do. I'm going to use a video cassette recorder lamp. And seeing as we still service video recorders, I haven't got many of these. And they are vital that the current consumption is just so, because it's a sensor. So it's a silly thing to do, but I want to get this set out. Now I've ordered some more lamps. And at the same time I thought I'll get some red ones, because I've had a bit of a run on red ones. And you get a transmit light inside the meter on Mustangs, on those D'Amico convoys, one or two other sets like that. And thought I'll get some red ones. They've discontinued them, haven't they? So that's going to be fun. We'll be painting white ones red, won't we? Dipping them in paint when I run out of the 2 I've got in stock. But they've still got some green ones, and you get them on the receive light on 1 or 2 sets. And you can't just shove an LED in because the circuit does something weird. So I've taken the front off, and on this set that leaves the meter. Oh, this is so straightforward. Or is that because there's something else? No, that's the lamp, isn't it? Hang on a minute, is that, there's 2 lamps. So is that a transmit lamp, which I hadn't spotted? Let's put the power back on. Perhaps that's not working too, and perhaps that's supposed to be red. That's supposed to be a red TX light, isn't it? Yep. So both lamps are out on this set. And we've got one video cassette lamp. There's nothing. Well, I'm going to say, what can I do? I can change that. So on this set, it's on a little holder, which is supposed to be flexible plastic. So I'm going to take the power off again. But they've usually rotted with the heat. I'm even more confused. The red lamp, which had failed, is inside. I've got 2 red lamps left, so we're going to have 1 red lamp left. So that one on the outside is the normal lamp, and hopefully our video recorder lamp will fit in the holder. Just like that. Now it may be different current. So we may have to change the dropper resistor. So I'll soon only have one of these lamps left, won't I? The red ones. We'll be going out buying some Humbrol enamel and dipping it in the pot. I wonder if Mr. Chippy's model making kit's got one to nick. So we're going to look at that preamp tomorrow. Or another set's just come from Alan, so we might be looking at his other set. I think that just simply goes to the power rail of the on and off switch. I didn't try this video lamp before I started fitting it. That was silly. Supposing it doesn't work and I'm wasting my time, and this video will be longer doing this than the actual repair. I think it's most sensible to cut these off, or you end up unsoldering all the other things which go to the on and off switch. So it couldn't be more straightforward. The positive goes to the on and off switch, the negative goes to the dropper resistor or the ballast resistor, and that sets the brightness. But of course when you're changing the lamp from one value to another, because they're going to be different milliamps, the ones we normally use are 80 milliamps, then there's going to be a different power consumption, so it's going to perform differently, which is why we sometimes have to change the resistance. Right, so let's power that back on and see what happens. That's exactly the right volume. That's exactly the right brightness. It's difficult to show on a video because you know you've got AGC in the camera, but sat here, that's the right brightness. It's not, it's not like a full whack brightness, which is something I could probably demonstrate. But you know what? Because it's running at 13.8, but I'll tell you what, we'll drop it to 12. I'm going to drop the power supply to 12 volts, and then we're going to short out the ballast resistor to show you what full whack brightness is for a second. So that looks like an earth point. You can see that? That was full brightness. Right, now we've got to deal with this one I wasn't expecting. I'll go and have a look where we keep our lamps. Okay, so here's our last two red ones. Leaving one last red one. What I'm going to just do is snip those off, withdraw it, thread the new one through, put it into the holder, thread it into the first of all thread it into the holder. We'll put that in the side of the meter and thread it through the other way. You know, you wouldn't think, how many hours has this transmitted for? Because they're about 200 hours life, these, and you just wouldn't expect the transmit one to fail. But it may have been that, if you notice, one of the wires was off. It wasn't me that pulled that off, and it's possible that it's corroded off. It's quite possible that lamp's really okay. Right, just need to pull that through. Slide the meter back. We'll cut those wires about there. Of course, it could be an electronics malfunction stopping it lighting, and the fact that one of the wires was off was a red herring. Red herring on a red light. So one goes there. Right, we'll switch the set back on. And press transmit. We've got red light. Done. Front back on. So if we felt that was too bright, then we'd increase the dropper resistor. But it's actually exactly right. Well, I never knew, you know, I can't even remember that these had got a red lamp in the meter for transmit. And it's not that long ago that we had a 402 MPa. And it's one of the few versions of this chassis where they haven't used the pesky Roger Bleeb. So we've now turned the set with 3.4 watts transmit, was it, into one with 4. We've got the correct deviation. We've got fantastic receive, better than nearly any set you can ever mention. And the squelch works. You know, it's certainly one of the better ones. And it must have done some right hours for it to have burnt that meter up lamp out. So he has we did a York 861 for him, and that was exceptionally good. Another of those sets with 0.2 something receive, which you don't usually get on those. And this is another one where it's off. This one's gone off the clock. And you can see, I mean, it's had to have a case blow over with paint, but it's come up trumps. I think these were $79.99 at the time. There's not much on the market these days that's going to perform like this. I'm actually looking forward to doing tomorrow's preamp repair. We'll probably have to do a CB as well, but if I can get the preamp sorted. I've never had to service one of those. Now we've got a nice preamp here for comparison. We've got the oscilloscopes, we've got the signal generator, and what I plan doing is we've got 3 of those dreadful Cobra 29, whatever looked like a Cobra, very swish looking sets, which work dreadfully. And when I bought our original sample, it was so deaf, I bought another sample from another source, and that was just as bad. And then we've had customers send in a couple, and they've been just as bad. And it's the only time I've said to a customer, to be honest, you're going to have to use this with a preamp because it's not deaf. They're not faulty, they're just dreadful, like 2.5 microvolts. And they're all the same. So unless somebody else has got one which is fantastic, the 5 we've seen and the 3 we've still got are dreadful. And so what a candidate to test a preamp on. Because normally you're not going to get it. If I put a preamp on this, you're not going to get better range because the receiver in this is fantastic. But on that, it will make a difference. And so that's going to be a really, really good test because we're going to be able to put that set on the bench and show a before and after, where you couldn't do that with this. Except with a set with an RF gain, or you could cheat the figures, still demonstrate it, but you'd have to do it by jiggery pokery. So there we go. Got a lovely Harvard 402 MPA. It's got the miles on it. I'll turn my test gear off. And yeah, the internal speaker works. Just check his microphone. So will we hear any good buddies on at Nottingham swearing like we usually do? So while it's on channel 20, we'll swap our mic for his mic. I'm just talking to our walkie-talkie. I sometimes call these talkie-walkies because we had a customer when I was at Nottingham Radio phoned up, and they said, "Do you do them talkie-walkies?" Yes. Another customer said, Now, it says here you do two-way radio, but what we want is three-way radio. I was thinking, what, you, me and God? I knew what they meant. What we call a basin 2. Testing 1 2, testing 1 2, testing 1 2, testing 1 2 1 2. That sounds fine. I'm going to tell you what, we'll still be using our mic for the tests, and then we'll go over to the customer's mic at the end to our base station. So let's just listen to our mic. Testing 1 2. It's probably identical, but it could be crisper. I've only got about 2 of those left as well, and that's the end of those as well. Right, we're all done. Flick round the channels. 19 a Roger. Absolutely nothing. Now that meter's showing S4, so let's unplug the aerial and see whether it drops at all. It drops to about S1 and a bit, so there's a bit of noise out there. But we've also got a loose connection, but I don't know what it's on at this stage. It's actually on this intermediate connector, so what we're just going to do with that is I'm just going to pinch up the 2 receptacles there, and hopefully that will be a cure. Not quite. The other thing to check under these circumstances is the fuse holders. Somebody's using car fuses. So what we'd normally do is just get the fiberglass brush on there, on the other one, on the fuse, What's he saying? Burner on, burner on, burner on.
Who's not working?
Well, no, Roger.
Oh no, I didn't switch it off. I'm just saying burner on, burner off, burner on.
Yeah, that's what you expect, isn't it? Thanks for watching.